Hello everyone, I'm Eugene from Garmin's product training team. Last time, we introduced how optical heart rate on watches. Today, we'll talk about how a heart rate strap measures heart rate. A heart rate strap measures heart rate using the electrical signals produced by the heart. So essentially, a heart rate strap is a chest-worn, ECG-like device. But before we explain how heart rate straps measure heart rate, let's first talk about why the heart beats. Inside the heart is a natural pacemaker called the sinoatrial node. It generates electrical signals to maintain heart rhythm. Once the sinoatrial node sends out a signal, the signal is received by the atrioventricular node. It then travels through the bundle of His, conducting to the heart muscles to trigger contraction and heartbeat. This is similar to electrical stimulation used in acupuncture, or during rehabilitation, electrotherapy, where muscles twitch in response to electrical signals. Looking more closely, the electrical signal is generated, conducted to the heart muscle, and triggers contraction and relaxation. This process creates changes in electrical potential. If we place a sensing device on the surface of the body, it can measure these time-varying electrical potentials and do so with millisecond-level precision, capturing the timing and frequency of electrical signals. Devices like this include familiar electrocardiogram machines, and heart rate straps are designed using the same principle. If you turn the heart rate strap over, you'll see two areas made of a different material. These two areas are the electrodes. When the heart rate strap is worn, the electrodes sit against the skin and begin detecting the R wave and the QRS complex. The QRS complex is a characteristic waveform on an ECG, representing electrical changes during ventricular contraction. The R wave is the peak of this waveform, making it the easiest to identify. It's also the reference point used to calculate heart rate. As the strap detects multiple R waves over time, it can calculate beats per minute. Because the timing of each R wave is slightly different, that means the interval between R waves is not exactly the same. It may vary by a few to tens of milliseconds. This phenomenon is called heart rate variability, or HRV. By measuring this time difference, or HRV, we can assess fatigue and recovery status. Whether you're a runner, cyclist, or strength training enthusiast, if you care deeply about accurate heart rate during high-intensity intervals and need precise, real-time measurement or even a few beats per minute data, then a heart rate strap is the right choice. If you're like me and have poor peripheral circulation in cold weather, or have tattoos where you wear your watch, a heart rate strap will be essential equipment. I once had a friend ask me why her optical heart rate readings were inaccurate and fluctuated so much. I tested her watch alongside two others, and all showed normal readings. Just as I was puzzled, I suggested she try wearing a heart rate strap. We paired it with her watch to measure heart rate. What really surprised us was that the heart rate graph she saw on her watch wasn't continuous at all, but showed brief dropouts. She later consulted a doctor, and some issues were indeed identified and treated promptly. I suddenly realized this experience with my friend was actually worth sharing with everyone. Earlier, we said heart rate straps are ECG-like chest devices. So why can't they measure ECG? And why can watches like Phoenix 8 and Venu 4 measure ECG without a heart rate strap? The reason is that ECG uses 12 different leads, representing 12 body locations. The strap's position doesn't match any of these locations, so it doesn't meet ECG lead definitions. That's why heart rate straps can't measure ECG. According to the U.S. National Library of Medicine, Lead 1 measures the potential difference between left and right arms. A watch worn on the wrist fits this requirement. That's why it can measure ECG. If there are topics you're interested in, feel free to leave a comment below. See you next time in the Garmin Principles series.